Thank you.
That's great. What are the questions? Let's get a little bit more together.
Did we forget to get? Because we can always, yeah.
Good afternoon. This is Pat O'Connell calling to order a special open meeting on Friday, June 16th, 2023. It's going to be a discussion in case number 23-00188 UT, which is an inquiry rulemaking pertaining to investor-owned electric utilities and reliability metrics. So Commissioner Ellison is leading that effort. So I'm doing my duty as chair to call this meeting to order and get the agenda approved. And then I'm going to turn it over to Commissioner Ellison to run this proceeding. So Ms. Amer, could you go ahead and call the roll?
Yes, Mr. Chair.
Here.
Commissioner Aguilera,
Present.
Commissioner Ellison.
Present.
3 commissioners are present. We have a quorum.
Thank you. So next is consideration and approval of agenda. We've gotten an agenda posted. There is an ongoing reliability problem in Southwest Public Service Company service territory, not in New Mexico and Texas. So we want to be respectful of that. Like one of the people presenting here has got maybe more important duty today than sharing the workshop information with us. So anyway, I would propose we keep the agenda as is. My understanding is the gentleman from Southwest Public Service who's going to be presenting is in a meeting right now. So if we just, well, I propose keep the agenda as is, and then if Zoe or Mike tells us that it'll work better if we rearrange the order, the other utilities, I appreciate a little flexibility on that. So having said that, commissioners, do you have any changes to the agenda?
No proposed changes.
Okay, so seeing no disagreement, approve the agenda as posted. And then, as I said, I will turn it over to Commissioner Ellison and Art O'Donnell.
Thank you very much, Mr. Chair. I had asked Mr. O'Donnell if he would mind facilitating this meeting, if that's still okay with you, Mr. O'Donnell.
Yes, it's fine.
So we have on the well, I'll turn it over to you.
All right. Thank you very much, Mr. Chair, Commissioners. This is an inquiry. The Commission is looking at what ought to be done about standardizing reliability reporting and getting a better understanding of how reliability metrics already do and can in the future influence utility investment decisions, especially in the distribution function. Earlier this month, the Commission issued a bench order request for data from the 3 utilities who all responded before the end of business on Wednesday. Response to a couple of dozen questions that we asked them, and their responses are going to form the basis of their presentations. I'll just say at a high level, it is apparent that the utilities are collecting what are considered the standard reliability metrics known in the industry as SAIDI, SAIFI, CAIDI, and ASAI, which measure the number, extent in terms of duration, and affected customers by outages on both a territory-wide basis and for individual circuits. And so we were pleased to see the level of data that the utilities were able to provide us. This data is reported inconsistently to the state regulatory agency. There are filings that are made on safety and safety to the Federal Energy Information Administration, as well as information about major outages that come into play in the determination of those metrics. But PNM gives us an annual report. El Paso Electric says it files an annual report, but I haven't been able to find it. SPS will respond to staff requests periodically. So one of the things we're looking at is standardizing the reporting and getting a better sense of how this information can be used. We do have the 3 utilities present with us today. Unfortunately, I do not have who is going to be presenting for EPE, who is first in order on the thing, but I'll turn it back to Commissioner Ellison at this point for any introductory comments from him.
Thank you very much, Mr. O'Donnell. Chair O'Connell or Commissioner Aguilera, do you have anything you'd like to say in the way of introductory remarks?
Yeah, I just want to say thank you to Art for framing that up, and then thanks to the utilities for coming in to talk through this. I mean, how I'm looking at it is exactly as Art said, is we want to understand the data that is important and then understand how and when it should be reported in a way that really meets the goal of regulating utility in a reliable way. So that's the formal version of it. The informal version of it is hopefully you don't feel like this is a trip to the dentist office. We just really are trying to understand. So, thank you.
Yeah, I want to echo those comments, and also, thank you, Arthur, for sort of laying out the situation here. So one of the things that I sort of have come to learn since starting at the PRC is just how unique each of the 3 utilities is. You have, despite being in the same state, you have different load profiles, different generation mixes, and different responses here for how you approach reliability. So I hope that this workshop will be informative for the 3 utilities to be able to learn from each other as well. I mean, I know this is going to be informative for me. And so I just, want to thank you all for putting this information together, and Commissioner Ellison for leading this effort, and Arthur O'Donnell for working with him in doing that. So look forward to it. Thank you.
Thank you. I'd like to say I appreciate the effort of our 3 utilities in getting these questions answered under a fairly quick turnaround. Reliability is keeping the lights on, and it is job number 1 for our utilities. The quality of service is a key concern to consumers, and it is therefore a key concern to the PRC, and is one of the aspects of service that we need to focus on. I think we've seen with some of the grid modernization requests, claims being made about reliability improvements. In order to judge those improvements, we need some sort of a baseline. And I think in looking into this area, we understand that the PRC is currently not receiving consistent data, or in some cases any data, without a phone call from our staff. We clearly do have an interest in getting better information about reliability, but perhaps even more importantly, to understand what utilities are doing with that information when they calculate reliability metrics. How does that impact their investment decisions in their distribution network? I'd also like to say that Lawrence Berkeley Laboratory has agreed to provide some technical assistance to the PRC and to all of us in this reliability issue. I'd like to introduce Jason Ball, who is with Lawrence Berkeley Lab and is on the Zoom call right now. He was with the Washington UTC, the commission in Washington for 10 years. And we anticipate that he will help facilitate a couple of our workshops. He has a practical viewpoint as someone who was staff in a regulatory agency in developing and implementing rulemaking. So I am confident that he will help us out greatly. Jason, is there anything that you would like to add?
Not very much. I appreciate the introduction, Commissioner, and I'm looking forward to working with you and the utilities to provide whatever technical assistance LBL is able to.
Great, thank you so much. At this point, I'd like to turn it back over to Arthur O'Donnell.
Thank you, Commissioner. I haven't got confirmation about SPS, so we're going to move ahead with El Paso Electric. And to EPE representative here, and can you introduce yourself, please? First of all, unmute yourself. Here we go. People live and in person.
Good afternoon, Mr. O'Donnell, Chairman, Commissioners. My name is Nancy Burns. I noticed that I'm probably the only utility attorney in the room, and typically that's not who you like to hear from during technical workshops, but it does. Well, Zoe has a new position now. She's actually acting as an attorney. So anyway, but it does sort of help. We have 3 people that are online that are going to speak, and it just sort of, they're technical people that do technical jobs. They have been involved. Ty Pollard is here. He is our manager of distribution systems. He's been getting more involved in commission workshops. But it does sort of help sometimes to have a little bit of an introduction to sort of get them going. So that's about it. I would like to respond to Mr. O'Donnell's comment about EPE not submitting an annual metrics report. We informally, Jack Sidler had asked EPE several years ago to annually provide the major indices, this 80 SAFE. Maybe we provide the Katie to him. I can't remember. We've been doing that by email. We send it to Mr. Sidler. And we also, since our merger docket was approved by the commission in our recent acquisition, we do have a reporting requirement. So we duplicate it and we file it in that docket, but it's just simply the metrics. It's not, we don't have a separate reporting requirement like PNM to file a report. So we're happy to get that information or any information that you need supplemented after today. We've got 2 people online. We have Jason Villanueva. Jason, are you on?
Yes, ma'am. Can you hear me?
Okay, yeah, we can hear you. Oh, good. Okay, so Jason's on there. I think what I heard is that the YouTube link wasn't working. So I'm not certain, but the Zoom is working. So we've got Jason on. And he will start off our presentation sort of, it's just a high level following the prior comments that were filed. And then Ty will talk, and then we have Leslie Chegnon, and she is our Senior Director of Distribution Design. So, and maybe if it's conversational, people can just answer the questions that you have. So that's all I have to say. Thank you.
All right, Nancy, thank you very much. This is Arthur. I apologize if it makes you look like you weren't doing what we asked you to do. I believe you're going to be running your own presentations and asking Patrick to advance the slides. The commissioners, of course, can ask questions at any time, so be prepared for that.
Yeah, so I'm assuming that Patrick will put up our presentation. We sent it to him.
Yes, it should be up.
It
now.
is. So if you could advance the slide, these are the introductions of the people who will be speaking. There we go. And then Jason, you could just start with the next slide.
All right. Good afternoon, everybody. As Nancy mentioned, my name is Jason Villanueva. I got a couple of slides here, going to be brief and try to be brief, but happy to answer any questions that come up. So the first slide is basically one of our responses, right? It just summarizes our response to our SAIDI, SAFE, and KD with major event days. As you all may already know or may not know, SAIDI is the average duration. If we're to get all the customers' average outage time and spread it out evenly, that value would be, it's given in minutes. We do give it in minutes, 123 minutes, for example, in 2022 was the average.
Yeah, hey, Jason, we're having a hard time hearing you. I don't know if you could change your microphone settings or what?
Okay, let me try something real quick. How's that sound? Yes, I found a setting that I think might have improved it. How does that sound?
Much better, thank you.
Okay, thank you. Should I start over or to pick up where I left off?
Pick up.
Okay, so I'm just talking about SAIDI, how that's the average duration for our customers, right? On average, if you spread evenly how many minutes a customer was out of lights across our system, our New Mexico system, for example, is about 2 hours. That does count repetitive outages for the same customer. It does include customers with no outages, so it's just a mathematical average. And SAFE, on the other hand, is our values for interruptions, average number of interruptions per customer system-wide. And in this, the units here are interruptions. So the 1.4 in 2020 indicates that across the system, our customers saw 1.4 interruptions. Again, it's a mathematical value that includes customers with 0 outages and customers with multiple outages. And we are following the IEEE standards for those definitions. And our KD, that's more of an operational metric more than reliability, I think, personally, because it kind of has for the customers that did see an outage, what was the actual length of the outage. So this actually measures our response to outages as a utility. So in 2022, you can see that our KD was actually lower than our SAIDI, which implies that we actually restored more than half the customers in half the time of the duration, which would cause KD to be lower than SAIDI. That's not always the case. Other years, KD is more, but KD is basically our operational response to an outage. And so we do track that, which is just as easy as dividing SAIDI by SAFE. And again, this is with major event days. The next slide. We do tend to be pretty consistent on our reliability in New Mexico. This one is excluding major event days. Now, major event day for us as a utility, they're hard to come by. We have about 1 major event day per year, maybe 1 every 2 years. So we don't have a lot of major event days in our system. So our values will be very similar in both charts, with the exception of 2021. What we do, however, one thing to make note of is that we do calculate our MED based on Texas, New Mexico performance combined, because our system, our distribution system as a whole whether it's Texas or New Mexico, we do respond with the same resources, and we treat both. For us, New Mexico and Texas systems are connected. There's no difference in how we respond to either one. We respond to both the same. We have a dockyard for New Mexico and 2 for Texas. And so operationally, there really is no difference between the states. We actually don't compare ourselves to other utilities in New Mexico because of as you might have seen by now, there's not very much data to compare with. But we do compare ourselves to Texas quite every year, actually, because in Texas, we do break up the information by forest, outside, and major event, and it's a little more granular, and it's per month too. So we do compare ourselves to Texas, and I want to say in the last 10 years we're either number one or about 90% of the time we're number one when it comes to reliability in the forest category, in the distribution category. Now you can see here that we did have something significant happen in 2021. That was a major storm that swept through both territories. Typically, our storms don't sweep through the entire territory. It might catch a portion of it. And typically, our Texas area is a little bit more condensed and more impacted by major events. So New Mexico doesn't have too much of its fair share as far as major events. Not to mention that it's a smaller portion of our system, which is give or take about 20% of our system is in the New Mexico area. With that said, we can go on to the next slide. This here, we did a causation table. We do actually categorize over 20 categories in our data for outages. These, however, are just the top 5 contributors to SAIDI in the last 5 years. As you can see, weather is significantly impacting our SAIDI. The weather is, and weather basically determines our reliability for us. The weather will always do that for us. It's always, every year, it is the significant impactor for us. And as I mentioned earlier too, since we don't really qualify a whole lot of major storms as major events, a routine storm that comes in does not get qualified as a major event, and it will hit our regular reliability figures. In most cases, the storms do not qualify as major events, as I mentioned. And as you can see there too, the second leading cause contributor is our equipment failure category. And as you all are probably very curious to know about, we'll talk more a little bit about that later and how we invest to minimize that value. We can move on to the next slide. As you can tell,
Sorry, can we back up? Because I had a couple of questions on that one.
Yes, sir.
It's just curiosity. Can you characterize what would be unknown, if that's possible? The known unknowns, or
Sure. That's basically whenever we restore service to customers and no repairs were made and nothing was found. A breaker might have opened up and we patrolled it. Nothing was found. We closed the breaker back in and everything held, and we did not find evidence of what caused it to open. We found a fault. In other words, our equipment did record an actual true fault. So it wasn't an equipment failure per se. A fault was recorded, but nothing was found. And so that categorizes as unknown.
great. And then similar utility error, is that?
Utility error, we keep track of that. What that is whenever load is dropped due to some sort of personnel error, maybe some bad, somebody input bad settings into the protection that caused the miscoordination part, or maybe there was some maintenance going on at the substation and personnel accidentally dropped some load, something of that nature.
Okay, thank you. That was very helpful.
Okay. So back to safety, you can see that 4 of the 5 causes remain in safety. Safety is also impacted primarily by weather, and then 3 of the other same causes as that were in SAIDI. And so the new one here is bird, and bird has a high customer count. A high outage count, but a relatively low impact to safety. And we actually do invest in bird protection as well, but we can talk more about that later. And one thing to point out too, as far as major events, is we do prepare before a major event. We have a very robust, in my opinion, a very robust preparation for a storm before it rolls in, if it's foreseeable. And I believe that's all I have from my section. I can pass it on to Ty unless there's any more questions.
All right, thank you, Jason. As Nancy said, I'm Ty Pollard, Manager of Distribution Systems. The section I'm going to go over are 5 of our programs that are reliability metric based or other factors in reliability based. So next slide, please. Those programs include the worst performing feeder analysis program, the pole inspection program, our cable replacement program, transformer threshold capacity analysis, and our vegetation management program. Next slide, please. Okay, the major program that uses reliability metrics specific is our worst performing feeder analysis program. We do use SAIDI and SAFE values from a previous year to determine the top 10% worst performing feeders for that year. And based on that, we have 70 circuits in New Mexico. So we do a minimum of 7 feeders per year. Sometimes we do a few more, but what we do is we go back and analyze the outage data for every outage, and we determine what were the biggest determinants for creating those metrics. And then within this current year, we take action to improve those metrics by taking or submitting recommendations for different types of activities. Those could be anything from coordination and protection concerns. We could change out fuses, things like that. If that's determined to be the biggest hitter to the metrics, we could change protection settings if that's the case. We also focus efforts on infrared scans. So for those worst performing feeders, we do infrared scans on the big, large equipment, GOPTs, reclosers, getaways, things like that. We can also do, depending on what the results were, if it's like tree trimming or debris in the line, we'll request additional feeder patrols, and we'll have people go look at the circuit and make sure that we have appropriate clearances and things like that. And then also we replace or install additional equipment. We could install reclosers, switchgear, GOPTs, things like that. If we needed to improve safety numbers, right, we could sectionalize the circuit by introducing more of these items into the circuit. So we take efforts to make sure that the worst performing feeder is not a concurrent hitter on our system. So for this program, it's essentially a year of performance and then a year of correction unless we have other concurrent issues, if it's a double hitter, things like that. All right, next slide, please. Our next program is our pole inspection program. And what we've done is we've sectionalized the entire service territory for both New Mexico and Texas into a series of grids. Within these grids, we have maybe a single structure up to thousands of structures. And we do analysis on the age of the structures. We look for structures that are 10 years and older, or if a worst performing feeder circuit travels or touches a grid. And then we'll elect to perform in New Mexico 3,500 to 7,000 pole inspections in a given year. What our target is to attempt to get to a 10-year cycle. Right now, we vary between 10 and 20 years because with the consultant that we're working with, we found that we start seeing failures at about 20 years. So we're trying to get ahead of that. All right, next slide, please. We also have a cable replacement program. And this is a geographical program where we'll look at specific areas, maybe a couple of blocks or maybe an area that's larger. And we'll focus on the area with the most cable failures within that given year. And then we'll focus efforts again in the current year to perform replacements. And this doesn't have any input from SAIDI or SAFE metrics. It's totally geographic, but we do consider it a reliability improvement program. And then we have transformer threshold capacity analysis. We actually use meter data to aggregate customers that are connected to a single transformer. And we look at that information annually to determine if the consolidated loads could potentially overload service transformers. And then if we determine that it is, we actually perform upgrades every year to try and prevent any failures of any service transformers. And then the last program for today is the vegetation management.
Sorry, can I ask a question on what you just said about performing upgrades every year? Are you talking about like if you're looking at the same transformer, then you would upgrade it every year based on the usage data, or yeah?
They're different transformers. So once we identify a single transformer that could be overloaded, then upon replacement, we'll make sure that it's actually not going to be overloaded within concurrent years or up to 10 years. Essentially, of course, loads change, and it's possible that with EVs and things like that coming online, that a transformer that was recently replaced lands on the list in a concurrent year, and we'd have to upgrade it. But we perform this analysis through data collection and analysis of the meter usage every year, which we hope to actually improve with AMI. So we're thinking we're going to get better results through that system.
Thank you.
Sure. And then for vegetation management, we have a 3-year cycle on all our circuits. So 1/3 of the system is patrolled every year. Now, depending on how the metrics landed a worst performing feeder, we could ask for actually additional feeder patrols to be performed within that 3-year period. So that's our attempt to keep eyes on all of our circuits, and we felt that 3 years is a good time period to take advantage of a program like this. And then again, we're consistent in Texas too, so we perform these for both states because we do consider the service territory to be both New Mexico and Texas. All right, and then that concludes my section of the presentation. I'm going to pass it over to Leslie.
Okay, can you all hear me? Hoping, can you guys hear me okay?
Yes, thank you.
Okay, thank you. Thank you for allowing us to present to you today. My name is Leslie Shagnon, and I'm the Senior Director of Distribution Design, Construction, and Maintenance here at EPE. And I'm going to be covering the O&M and capital graphs that you all have requested. So I don't know if you are on the graph that's for EP's O&M based on megawatt hours. Is that what you're all seeing? Okay, there we go. All right. So I will be going over about 7 different slides that are going to be depicting EP's distribution, O&M, and capital expenditures for the New Mexico service territory only. I won't be covering Texas, so everything that you see will be for New Mexico. On these graphs, you'll notice the time frame that we're covering is from 2013 to 2022. And the graphs that are shown, you'll notice there's 2 bars for each year. So the gold bar on the left is the actual spend, and the blue bar on the right is the corresponding inflation adjusted spend. So this particular graph, the first one that we're going to go over, is for distribution O&M spend per megawatt hour in the New Mexico territory. And when you look at the inflation adjusted bar, which again is the gold bar, the O&M expenditure per megawatt hour is hovering around $3 per megawatt hour. And one thing that I did want to point out, and I'm sure most utilities are doing the same, El Paso Electric, we're really trying to flatline or reduce O&M spend. And you can see that, we had an uptick, and then starting about 2018, 2019, we're starting to slowly reduce that. So that is something that we're actively trying to accomplish as we move forward. Please go to the next slide. Okay, this graph depicts the distribution O&M spend per distribution line mile. And again, this is in the New Mexico service territory only. When you look at the inflation adjusted bar, which again is the gold, the O&M expenditure per distribution line mile in New Mexico is close to about $2,400 per distribution line mile per during the 21-22 timeframe. Please go to the next slide. Okay, this one is depicting O&M spend per retail customer in New Mexico only. And again, we're looking at the gold bar per retail customer in New Mexico. It's hovering around $53 per retail customer during the 21-22 timeframe. And when we talk about retail customers, basically that's all of our customers in New Mexico, since we do not have wholesale customers in New Mexico. So that's all different categories of, residential, small commercial, large commercial, industrial. That's all customers for us in New Mexico. Okay, please go to the next slide. Okay, so now we're leaving O&M and we're going into capital. And you can see that we have had a significant increase starting in about 2018, 2019, I guess, on our capital spend. And this capital spend, we're doing it in Texas as well, but certainly in New Mexico. And we're really focusing on not only improving our reliability for our customers in New Mexico, but we're also having to provide service to new customers and also to prepare for long-term growth on our distribution system. So, we've got EVs coming, refrigerated air, just preparing for the future. This is the spend that we are seeing in New Mexico. So when you look at, again, the gold bar, the blue bar, I've been saying gold the whole time. The blue bar is the inflation adjusted. The capital expenditure per megawatt hour was about $14.50 per megawatt hour in 2021 and $13 per megawatt hour in 2022. This is our capital spend. Please go to the next slide. Okay, this graph depicts the distribution capital spend per distribution line mile in the New Mexico territory. And again, we're going to look at the inflation adjusted bar, and apologize, it's the blue, not the gold that I've been telling you. And in New Mexico, we're spending about $11,000 per distribution line mile for 2021 and $10,000 in distribution line mile in 2022. Then our last one that we're looking here is distribution capital spend per retail customer in New Mexico territory. We're looking at about $243 per retail customer in 2021 and $220 per retail customer in 2023. Please go to the next, or I'm sorry, that should be 2022. And this last one, the last slide that I'm going to go over, this is we're looking at basically all of capital spend in New Mexico, and these numbers are not adjusted for inflation, so these are actual spend numbers. So this is a little bit different graph. We're still looking at the same time frame, 2013 to 2022 in this, and hopefully y'all can see it, but the blue bar is depicting new customer connections, the spend for that. The orange bar depicts expenditures for managing our reliability. The gray bar depicts expenditures for long-term distribution planning goals. And then the gold bar at the end is the total distribution spend. Sorry about
Could
that.
you please elaborate on what the distribution planning goals is?
Yes, I will. I'm gonna get to that. So let me, I'll kind of cover each one of those, try to explain it to you. I did want to mention, we're lucky here at El Paso Electric. We're still seeing a load growth where I think a lot of utilities are flat or even declining. So we're still seeing about a 1.5% load growth average over the last 5 years in New Mexico. As far as reliability, and managing reliability, because you all had asked for these different buckets, right? You asked for the new connections, you asked for reliability, and then the long-term distribution planning. And so at least for El Paso Electric, the lines kind of get a little blurry because we do feel as we're planning for the future, we're also improving reliability. But we did kind of bucket it to the best that we could. So for example, when we're reconductoring an existing line to meet future load growth, we know, we've got load coming on and we need to reconductor, upsize the conductor. We're meeting our long-term planning goals, but we're also improving reliability because we're upgrading and taking out old equipment, upgrading to newer equipment. So in our mind, we're kind of handling both buckets of the long-term planning. We do have a distribution 10-year plan that we put out every year that, we're planning for growth that we know is coming our way, but we're also improving reliability for all the customers that are on that line. Now they have new equipment that's, less likely to fail. That's one example. Also, building a feeder extension out of a new feeder substation, we're meeting long-term growth, but also when we're doing that, we're giving our customers they're on a line now that has more capability for switching. Say we have an outage, we have more lines out there, we can do switching and get people in quicker. And so that's improving their reliability, and it's also meeting our long-term growth. So, so we kind of view reliability and long-term planning kind of the same, but we do have some programs, and most of them are what Ty had kind of went over previously for reliability only, and I'll kind of cover that. So mentioning again, so our buckets are residential, the commercial, services and metering is what we put into our customer connection bucket. So, any new customers that are coming online, any service drops to those customers, and of course, all the metering, that's what we're calling our customer connection spend. For the distribution planning goals, we're trying to meet the long-term growth, as I mentioned, and improve the reliability. And as I previously stated, starting in 2018, we've really been spending a lot more on our capital expenditures, including in New Mexico. We've had a lot of growth, as you guys are probably aware. Las Cruces is just blowing up. A lot of people wanting to move there, live there, open up businesses, which is great for us. And so some of our most notable projects out there are, we've got Moongate feeder extensions, and that's in the northeast of Las Cruces. We've seen a tremendous amount of growth. So we did a lot of work in Moongate, and that was starting in about 2019. Also in the northeast area, we had the Jornada feeders. We started that in about 2021. We've also been working, we've got a line that goes out to Hatch, and we've been working on that for many years, actually. We had a significant uptick in 2019 and 2020 for that line to provide better service to our customers and reliability to our customers. Of course, we had our New Mexico solar interconnection in New Mexico State University, which we're really proud of, and that happened in 2020. That was a pretty significant expenditure. And then also in the southeast, we've had some pretty significant load growth of Las Cruces, and Talavera was worked on in 2021 and 2022. So those are some of the major projects, but we really have been increasing our spend for load growth, but also again for reliability. And then the last bucket that I mentioned, so we have the new connections, and then we have the load growth, but we also have reliability that are strictly more kind of short term. So we're kind of looking at reliability is, 0 to 3 to 5 years. And then the long term, we're looking at the 10-year long-term planning. And so these are kind of going back to some of the projects that Ty mentioned. We have our underground cable replacement program, which we're looking every year. We have an analysis done on cables that are failing, and we go and replace them. Another one that we work on is our New Mexico 4 kV conversions. We've got these old substations that are 4 kVs, and they're so old that a lot of the equipment is outdated. You can't even get a hold of it. So we have a very active program of replacing these 4 kV substations to distribution pad mount gear. And so that's a reliability project that we work on every year. We also have the osmosis pole inspection that Ty kind of mentioned, and this is really, we've seen a lot of improvement. We go out and inspect these poles, and where we can, they can treat the poles, and which prolongs the life. And then the poles that really need to be replaced, we get out and replace them. And we either, if they need to be replaced right away, we do that. Or if we can put them into the next year's maintenance splits, we'll do that. So we've got that as an annual reliability program. We're also upgrading our distribution capacitors out in our field. So previously we just had one-way communication to those capacitors, and we're upgrading those capacitors now for two-way. So we're able to see what's going on in the feeder wherever these capacitors are and control them. So that's a part of our reliability projects. And then also the potential overload transformer program that Ty mentioned, that's really been very beneficial. You know, we get ahead of the load, so we can really predict transformers that will and probably would fail if we didn't replace them. So we've seen a lot less failures since we've started that program. And that's, again, overhead and underground. Every year we do that program. And then the last bucket that I wanted to just mention is our distribution betterment projects. So we just have projects throughout the year that, you know, we're seeing issues on the line, and we bucket that into distribution, and that's a betterment project that's totally geared for reliability. So hopefully this kind of gives you a picture of how we've been spending our O&M. We're trying to reduce O&M, trying to be as efficient as possible, and trying to increase our capital spend to meet load growth, provide good service to our customers, and, you know, be reliable, have reliable service to them as well. So that's really all of the slides that we had. I don't know if you all have any questions for Jason, Ty, or myself.
Thank you, Leslie. Thank you, Ty. Thank you, Jason. Commissioners, any questions?
Yeah, thanks. I got just a couple. You know, Mr. Pollard, Mr. Villanueva talked about how we look at it as one system. Is there only one budget, or is there a separate budget for New Mexico and Texas?
Well, it's kind of broken out, but not really, right? We have budgets that we track through New Mexico and Texas, but it's an overall ask for distribution. We call it T&D, right? So it's across the territory. But, you know, we just for accounting purposes, we do kind of separate them. But it's an ask across the whole organization.
Thanks. And then the next thing is just, how does the overall ask work? I mean, how do the system needs get presented as part of the ask?
Presented to our senior management team, or
Like who's making the decision on the budget? Do you get a lump of money and you figure out how best to spend it, or do you present, this is what we need and it needs to be funded? And then who's in the room when the decision gets made to fight for the projects that have to happen? Right. Yeah, basically we do an analysis, and it's really kind of our distribution team. You know, we have our wants based on our 10-year plan that Ty puts together, him and his engineers. And then, you know, of course, we do have transmission, substation, and relaying, and they have their wants. A lot of the projects are, of course, interrelated, right? Our distribution feeder substations is based off of our substation build and transmission lines going to our substation. So we basically put this budget together. You know, recently we've had kind of a new management team at El Paso Electric, and they're called the executive leadership team, and they're very engaged and working together across the organization. And so we, you know, distribution, TSR, we go to our executive leader, Omar Gallegos is our VP, and he goes and basically has the conversation with the rest of the executive leadership team for, you know, we're talking PR, and we're talking customer build, all the different parts of our organization, and they kind of come up with solutions to who gets what money, basically. I will say that we've really seen a lot of success since we've been, you know, sold to IIF. They really have
one thing that they've kind of mentioned is if we can reduce our O&M spending, and we can take basically a reduction in O&M of $1 can allow us $10 more of capital spend. And that was what we were told when, we first were bought by them, and that really has been proven true. And you can see that in our, our increase in capital spend. So I think as long as we're able to execute on these projects, they are definitely there to help fund what we need. So that's just kind of how it goes. Omar could probably give you, I don't know if they get in there and battle it out, but we really are seeing success in having increased capital for our distribution system and transmission, substation, and relaying in the T&D organization.
Yeah, thank you. And then could you just remind me, when did the merger close?
Oh, gosh.
Basically, was it in between 2019 and 2020?
Yeah. Nancy, are you there? Let's see. I'm trying to remember because I remember COVID, it had already happened. Maybe 2019,
2020.
2020.
Just seeing
Summer.
that big jump in spend and wondering if it was related to the merger or not.
Yeah, it really has, I think that has improved our ability definitely to have more capital to spend. And so we're definitely thankful for that. I think it's going to be a huge improvement for our customers' reliability and be able to meet load growth and all the things that we have coming our way.
Yeah, thank you. Those are my questions.
I did want to follow up. A remark was made about the SAIDI data being for the combined system. Was that one of the two with the MED or excluding MED?
I believe you're talking about when I mentioned that we determine our MED threshold based on combined system data. But the data presented though was all New Mexico only. But in order to establish our MED, since our system as a whole, we establish our threshold MED based on total system reliability, or data rather.
I think I see. So you say you're defining what is an MED based on the, whether or what happens over your whole service territory, but the numbers you're presenting here were calculated for your New Mexico territory only.
That's correct.
Great, thank you. A mention was made about a cable replacement program. What criteria do you use for replacing underground cables?
I don't know, Ty, do you want to take that or you want me to?
Yeah, I can take a shot at it. So the cables that we're looking at are mainly the larger conductors, not necessarily service runs or anything like that. The smaller stuff that are on a per customer basis, main feeder type cables, loop feeds and subdivisions. And what we're looking at is a series of consolidated failures. It could have been a certain vintage of conductor that we purchased in a given year, and we're trying to identify it. The tool we use is helps us to identify where we get an influx of cable failures. We don't have we have more of a responsive program rather than proactive at the moment, because we're just not sure when we need to replace cables until we get these events that occur. And then we budget toward the region of focus that we believe we need to replace annually.
On the vegetation management, you were mentioning that you have a schedule of every 3 years that you're is that you're visually inspecting all of the feeders, or how does that work?
Correct. We send different personnel out for patrols. There, we have individuals assigned to specific circuits, and they're given the schedule to perform these patrols. And Jason, can you elaborate on how much they patrol? Is it, I believe it's mostly the large trunks and large takeoffs, not like the service drops and things like that. But can I get confirmation on that?
Yeah, I believe so. I believe the backbone of the feeder is what's looked at when they're patrolling these for vegetation. I mean, they won't stop there if they see something obvious though. I mean, they will take a look at the problematic areas.
But yeah, we do have a 3-year cycle. It's assigned to different personnel resources, and we keep track of it. You know, we know who has and hasn't performed feeder patrols, and we keep reminders on those. And then of course we introduce or influx those additional patrols if necessary, dependent on worst performers, right? So we could patrol the same feeder 3 years in a row if it does land on a worst performing feeder list.
But are you trimming vegetation on a more frequent basis, or is it when they're doing the inspections, they're also trimming vegetation?
I'd have to refer to, I didn't create the responses to the vegetation. That was one of our other directors. But yeah, we can get that.
Yeah, and one thing I do want to mention is we're looking at launching a pilot project to where, and I'm sure other utilities are looking at this as well, where they basically go out and have a satellite image of all of our trees, and they take into account the type of tree it is, the growth of that tree, all these different conditions, and that gives us a more predicted or actual pinpointed area of where we should see tree growth, and so that we can go out and trim those areas. So we're going to be launching a pilot to do that, so that we can basically address the trees that really are in the lines and cut back on going out and spending a lot of time patrolling areas that really may not need it. So, if we have this workshop in the future, we can report back on how this pilot went, but that is something that we're looking to do relatively soon. And I think a lot of utilities are doing that, that kind of predictive tree trimming. So you'd be more pinpointed and have a little bit of science behind it of figuring out where to go to trim trees.
Great, thank you. I think that's all the questions I have.
I have a question as well. Going back to the last chart that we looked at on distribution capital spend, the one that includes all of it together. For the gray bar, the distribution planning goals, does that include capital spend on new and existing facilities? And was wondering if you could provide us sort of a percentage on how much is on new facilities and how much existing facilities. And to clarify, by existing facility, I mean like upgrades to existing facilities. Yes,
it does include both new and existing. And I don't know, Ty, do you have a percentage in your mind of what that? I'm not sure.
I don't have the data in front of me. I couldn't tell you what the percentage is. But yeah, we can
follow up with you.
Yeah.
Okay, and then the orange bar, which is managed reliability, that one seems to also flatline. I guess I'm curious whether this is similar to the O&M spend, where there is sort of a purposeful, trying to keep it flat, or sort of, I don't know if you could elaborate on that.
No, you're absolutely right. It does look like it's pretty flatline, but that is not something that we're doing on purpose. All of these programs that we've mentioned, they are done on an annual basis, so that could be why they're kind of the same value. But again, the reliability, kind of going back to what I was saying about the different buckets, you see a larger spend in the distribution planning, and we feel like a lot of our reliability improvements are captured in that distribution planning. So these annual projects that we have, like the cable replacement, the overload transformer program, those pretty much are the same spend year by year. Where we're seeing improvement is when we go out and reconduct an existing line and, getting all of the 30, 40, 50-year-old equipment off and with brand new conductor and insulators and so forth. So no, we're not putting a limit. That's just kind of how it's rolling out. We definitely want to continue to spend on reliability and increase these programs and keep them up. We do see an improvement in failures. So we know they're worthwhile, these programs that we've initiated.
Okay, thank you. I appreciate the response. Those are the questions that I had. I don't have anything else.
Commissioners, if I may, I have a couple of hopefully quick questions, two of them for Leslie. Leslie, you referenced a 10-year distribution plan. How was that conveyed to the commission?
Wow. That's a question for Ty. Do we send that to the commission? I don't know if we do.
It's currently an internal document. Since that document is more planning in nature, the programs do evolve through some of the process. We don't submit the plan as a whole, but I believe different projects are communicated at different points. It's not all consolidated.
Okay, great. And Leslie, in several of your slides, I kind of have to eyeball the numbers, but the difference between the actual or nominal spend and the inflation adjusted can be as much as 20% in a given year, apparently. Just talk a little bit about how the impacts of inflation may impact your decisions. For instance, because some component that you are looking at is cost much more because of inflation than another. Are you deferring maintenance spending in any way as a result? And generally, what have been the impacts of this? Because what I see is that the actual spend has increased significantly year by year, but it all really levels out a whole lot on the inflation adjusted numbers.
Yeah, as far as inflation, we definitely have seen, the cost of our distribution transformers have doubled, even tripled recently. So definitely seeing an impact into our, the costs that we're, the labor charges that we have for our contractors and even our own internal crews. So, we've continued to push on the projects that we've had on the boards, even increasing them. So, we're kind of battling through this inflation. I wouldn't say that we're really holding back on our spend. Of course, we don't have unlimited, but I think the company as a whole is continuing to spend where needed. And we do have to make, I don't want to make it seem like we have unlimited funds. We definitely have to make those decisions. We have to balance risk, and we look at all things that need to be done. There's tremendous amount of work that we need to do. But I don't see the company really holding back on spending the money to provide the maintenance and new growth construction that we need. I don't know if that answers your question.
Yes, it does. We're all dealing with the issue. We go to the grocery store. It's a lot more expensive.
Oh yeah.
Yeah.
It's unbelievable, really, right?
Yeah.
But
right. Well, thank you for a metric there that certain, and I presume that those are the pole canister transformers generally that you're talking about, doubled in price?
So all of them, all transformers across the board really have gone up tremendously. We've got through where we couldn't get a hold of them. We're working through that in a lot better space, but now just the cost is gone up tremendously.
Okay. A quick question for Ty. You said something that surprised me, which is that in your pole inspections, you're starting to see pole failures at 20 years. it was always my impression that poles could live longer than me, 50 to 70 years. Is this just because of the dryness of your territory or something else going on there? It just kind of surprised me.
We haven't looked at the details as to why we've seen those. But we have, most of them do last significantly or a lot longer than 20 years. That's the data that we were receiving, the consolidated data back from the pole inspection consultant, that they are seeing 20-year-old structures that are failing. And it hasn't been alluded to if it's in the valley by the river or differentiated between out if it's in a dry area in the middle of nowhere yet. So we're still looking into that.
Okay, great. Those are all my questions. Unless the commissioners have any follow-ups, we'll thank El Paso Electric for your presentation. And I'm
Yeah,
sure that
you
people are going to have further questions.
Just wanted to ask generally if, so this has helped me, and if putting this information together has helped you, and, is there something that you sort of realize maybe you'd like to improve on, or are there any sort of lessons learned from putting this information together?
I can chime in here. I think because we do a lot of manual analysis and calculations, definitely I think some of the technology is going to help moving forward. We're really looking at having better equipment installed out in the field, like smart devices that we can get information from a lot quicker to have better metrics, and then tune up some of the programs like we mentioned, the transformer capacity program. It was a lessons learned that, we really look forward to having the technology to make improvements on these types of programs.
Again, thank you very much for your presentation. We hear from SPS that they are not under a particular time crunch, so we're going to go forth with the agenda as set and ask the PNM representatives to either join the table or identify yourselves on Zoom.
All right, Chairman, Commissioners, Mr. O'Donnell, thank you for having us here today to go over some of our reliability information with you guys. My name is Carrie Salas. I am the Director of Regulatory Policy and Case Management for PNM. Here with me today is Wes Gray. He is the Director of Transmission, Distribution, and Substations for PNM. I also have with me in the room here today, Mike Mertz, who is our Chief Information Officer, as well as our VP of New Mexico Operations. On the Zoom call, I believe we have Omni Warner, who is our Director of Distribution Engineering and Grid Modernization. And I believe on Zoom, we may also have Rick Alvidrez, who is outside counsel for PNM. So Wes Gray is going to do the majority of the talking here. He's going to give the presentation, and we'll all just kind of be holding here for questions as they come.
Great. Thank you. Would you load their presentation, please?
Good afternoon, Commissioners. Thank you for having us. So first slide, please. So a little bit about PNM's reliability program in general. PNM has been involved in reliability benchmarking for about 20 years. We participate in the Edison Electric Institute's annual reliability survey, where we submit our reliability metrics to Edison, and they benchmark them across approximately 80 electric utilities in the United States. Those utilities cover about 80 million customers across the US. And so we've been monitoring that. PNM's metrics, we have been in the lower first quartile for our system average frequency, and in the averaging in the upper second quartile for average customer duration and average system duration. over that time frame. So PNM has been really spending a lot of time and effort monitoring its reliability metrics, and we use it as a driver in our reliability program. PNM service territory is unique. You know, it was mentioned earlier, the service territories of the three investor owns in New Mexico have different characteristics, different load profiles. PNM is pretty unique because we have a large metropolitan area being Albuquerque. And so that's a very urban environment, but we also serve some very rural service areas in far southwest New Mexico and southeast New Mexico and northern New Mexico. So when we talk about overall system metrics, all of those are averaged together. And so internally, we look at them by operating unit and analyze them that way. But when we do the report outs, we really look at it on a system level. The metrics we provide annually to the commission along with our annual report. So you see our data every year. The metrics can be varying. I talk a little bit about service area characteristics, and it's from heavy urban to forested to high desert. So we've got all kinds of different terrain types which affect it. We have feeder configuration and design, depending on the era a system was built and the location it was built in, it may be configured slightly differently in different service territories. In our southern New Mexico, specifically Ruidoso, Alamogordo, Silver City, Lordsburg areas, those came with the merger between PNM and Texas New Mexico Power. So they were built with different standards. And so those affect the reliability of those systems because they were, at the time, there were two different companies, and now being one, we're trying to consolidate that. Some other factors that go into driving reliability metrics in the more rural areas, it's just the sheer distance for some of our troublemen to get to an outage, to just take a look at it, to troubleshoot. And so that really drives those numbers in the more rural areas, where in Metro Albuquerque, Metro Santa Fe, it's not quite as bad because we can readily get around town and get to an outage a lot quicker. Some of the feeders out there on the system, and this is another design issue, is we don't have any kind of monitoring on these circuits. They're rather rural. So without that telemetry to be able to look at the condition of the system or look at an outage, we don't really have much information about the causes, where they might be located, until we get a troubleman physically in the field and get eyes on those feeders. And then depending on the age of the systems, we don't have a lot of automation on some of those rural circuits. So in the metro area where we have a little more of them, we can do automatic restoration, do some automated switching from our control center, which will help us restore feeders much, much quicker. We use our reliability metrics to proactively replace aging equipment, its poles, its underground cables, and try to prevent things from happening. So we're annually looking at our metrics, we're looking at our reliability trends, and we use that in concert with several other factors: age, the locations, the criticality of the circuit, a number of customers that are on individual circuits, transfer capacity of being able to, if we have an outage on one circuit, being able to transfer it to another. Our planning studies, we use selectively surveyed areas using LiDAR to determine any complexity that we might see. The criticality of a circuit to pick up load from an adjacent circuit. And we look at, reliability, but we factor all of those in making our funding decisions about how we invest our funds in our infrastructure. And on the kind of split, we'll show some slides later on capital versus O&M spending. When we get our year's reliability metrics, our game plan typically is we'll take our metrics, we'll analyze our top 10 worst performers to start with, and that's where the focus really is on a given year. We'll do line patrols for both line issues itself and or vegetation management issues. So we have two different teams out looking at those lines and verifying based on the top 5 outage causes of each one of those top 10 worst performers. So we're doing that analysis. We get out, we do those patrols, and we identify any deficiencies on those feeders. Then that drives the next level of it. Veg management clearing. If veg is a high contributor to outage duration or frequency on a circuit, we'll get veg management crews out clearing those lines. And on the capital side, we've kind of got a 3-tiered approach to doing it. We do short term, we'll go out and we do some minor maintenance on areas that we've had outages just to try to prevent that from reoccurring. Then we have a more medium term response where we do an internal program called plant unit replacement, where we go out and we replace cross arms, insulators, fuses, capacitor banks, poles, pole grounds, and we apply bird guarding to try to prevent, again, more recurrence. We don't want to see a feeder repeat on our worst performer list. And then in the long-term picture, we do comprehensive feeder rebuilds and cable replacement projects. And that involves more of our engineering and our planning folks, where we're looking at what are our system needs for flexibility, for transfer capabilities, again, age of equipment, and then we factor all that in as our prioritization method of which projects are more critical than others. Also in this, we have developed a wildfire mitigation plan to go out, and we have identified areas that we deem have a higher than normal risk of wildfire. And then in those areas, we have done intensified vegetation management and line patrols. So we're out inspecting those areas more frequently than we do the rest of the system. And we have utilized LiDAR technology to not only look at vegetation growth, terrain, gain some other engineering data, which will help us on the operations side as well as the engineering side of the business, but we also are looking at other technologies to do much the same. LiDAR is pretty expensive to get out there. We started a program for our wildfire mitigation. We started flying lines in late 2021, and we did not finish until early 2023 because we were flying fairly low aircraft with a helicopter mounted system. And with the winds and weather in New Mexico, it was problematic for the company to actually fly lines here. So we're looking at a satellite-based technology as well. We're piloting it this year to utilize satellite imagery to analyze vegetation management growth and look for those high-level things that we can fix and try to prevent outages on the system. Next slide, please. So we have PNM's 10-year reliability data for outage duration and frequency, and grouped together including and excluding major event days. Our metrics are calculated using the IEEE 1366 standard, as most of us are doing. We see general trends. One of the things for us really has been more about storms and weather changes in the last few years, and it's impacting our systems. So you'll see some variability in outage durations. More recently, we're seeing issues out there on the system where it's just taking us physically longer to do repairs and get customers back on. We're utilizing our internal workforce and contract workforce to do everything we can to try to reduce outage duration, but we've just been facing some challenges with that because of the type of damage that's out there. Specifically it's wind, and we're getting trees coming over in lines, which is just causing us quite a bit of damage, and pole replacements and having customers out are just driving those duration numbers up. One positive note is our outage frequencies both on either side, whether it's including major event days or excluding major event days, has been fairly consistent. We've seen good consistency and frequency, which tells us that our outages, we're not seeing more outages. They're about the same numbers, but we are seeing them cause more catastrophic damage to the system. Next slide. So these are our major event days since 2013 through the time period the commission was looking for. Things of note, most of these are involved with either thunderstorms or high wind events. Starting in 2020, we're seeing a higher frequency of high wind events in New Mexico where we're getting beyond just your average red flag day, where we're having extreme winds in portions of our service territory. It doesn't necessarily hit everywhere, but in some storms, we are seeing some pretty catastrophic winds. The bottom one listed, the April 2022 windstorm in Ruidoso, we had winds tracked around the Ruidoso area of greater than 90 miles an hour, which in case that exceeds the design capabilities of the lines, because they're just, at that time they were constructed, that was not a consideration. And we're seeing more and more of that occur. Also, in a lot of these wind events, again, I'll make that statement. We're seeing a lot more trees outside of PNM's right of way fail and fall into the power lines and cause damage. So far, for major event days in 2023, again, we have already seen 2 major event days in 2023 that had widespread damage throughout PNM service territory. Both of those occurred in late February, February 22nd, 23rd, and then again on February 26th and 27th. And we had damage in Silver City, Deming, Ruidoso, Albuquerque Metro, Santa Fe. So we had crews spread out throughout those service areas trying to get customers back on. And each one of them took approximately 48 hours to get 100% of our customers back on. Next slide, please. One of the data points asked for was customer outage duration. And for customers that experienced outages greater than 4, greater than 8, and greater than 12 hours. And, 2022 was a tough weather year for us. We had quite a bit of weather related issues in that year. And so our numbers are up for 22. 21 was a really favorable weather year. The last 3.5 months of that year were fairly quiet, no wind, no snow late in the year. And so the number decreased in 21, but we rebounded and made up for it in 22, unfortunately. And so we're seeing higher than expected numbers in that time frame. Next slide. And for customer outage frequency, we see consistency. The number of outages that are affecting customers that having greater than 4 outages, greater than 8, greater than 12, the numbers are not out of bounds. We're seeing similar numbers. We have a few outlier years, but the numbers are somewhat consistent as far as the number of customers experiencing multiple outages. So for us, it's a positive note that we're not having recurring outages affecting the same customers as often. Next slide. So it's a listing of PNM's 10 worst performing feeders for 2021, 2022, and so far year to date in 2023. One positive for me on the operations side of the business is we have very few feeders that are repeating year after year after year. And if a feeder does repeat as a worst performer, we have a far more intensive look at it. We get our engineering folks, our planning groups, and my operations team, and we do a deep dive into those outage causes to try to prevent that reoccurrence, try to prevent it from happening again. things happen out there on the system that we cannot control as a utility. We do our best to try to prevent that. But, you know, for me, we do a really good job of trying to prevent those worst performers from repeating. We really strive to work on our underperforming feeders out there. Next slide. So these are our top outage causes and the trends of those over the last 10 years. Some of the biggies for us are really trees, lightning. Unlike our counterparts at El Paso Electric, we segregate some of our equipment failures into different categories. So we have listed here underground cable failures. We list them separately. We have transformer failures as a different category. They're not showing up here, but so we break ours up a little bit. But depending on the weather year and where storms happen in the service area, you'll see various peaks and valleys driven by factors. You know, a lot of our tree related outages are weather related. It's wind pushing trees into lines. So during normal operating conditions with no wind, we don't have a problem. As the wind starts picking up, we see more trees getting into the lines. It'll trip those circuits out, and then we're out having to do some spot clearing in the short term, and then look at long-term scheduling of doing vegetation management on those circuits. Upward trends in the last couple of years significantly are vehicle caused incidents. We're seeing far more car equipment outages out there on the system, and they're becoming far more devastating than they have been in the past. Before, a car would bump a pole and it wasn't a big deal. We're seeing more and more cars just plow through and break poles completely off at the ground line. And then we're waiting for EMS to clear up those incident locations before we can get in there and actually do the replacement. So we've got to wait for them to clear the scene before we can even get in there and start work. So it's a challenge. Next slide. So this is our distribution O&M expense for the 10-year period. It's provided as part of our filing. Didn't provide extra slides to break down it in detail, but starting in that 2018, 2019 timeframe, we saw a need and we started ramping up in 2019 and really started increasing our distribution O&M expense. Some of the key factors we're seeing is aging infrastructure. You know, on average, our distribution poles last, from an accounting standpoint, about 50 years is what we're getting out of it. We see higher frequency in pole failures in areas where we have more moisture down near watersheds than we do in some of the high desert locations, because it's so dry in those locations. The poles are lasting 40, 50 years. So it's advantageous from that standpoint. Cable replacement, we're seeing failures on cable, typically on cables 30, 35 years of age, and trying to prioritize that cable failure. It's not just age. We look at age and number of failures on a particular run or a particular area. Typically, because of development happened, all of the cable in that subdivision, that development, are going to be similar aged. So we can identify those areas of interest where we want to start doing the pre-engineering to do cable replacements. So just some metrics, and I'm going to use the 2022 inflation adjusted numbers for distribution O&M. Our distribution O&M per megawatt hour is about $3.51. Our distribution O&M per line mile is about $2,825 per line mile. And our distribution O&M per customer is about $61 per customer in 2022. So, and as our trend shows, we've been increasing spending as our equipment and is getting older in age over the last 4 years. Next slide, please. So distribution capital over the same time frame, you'll see much the same trend over the last 4 years of an increased spending in distribution plant additions. Distribution plant additions per megawatt hour is running about $13.64 for 2022. Distribution plant additions per line mile is almost $11,000 per line mile. And distribution plant per customer is about $239 per customer. So significant funding has been put in to replace aging infrastructure, to modernize the grid, to provide better data on operating conditions and where problems might be out there on the system to help us identify and track it down. And again, go back to we're trying to have a proactive approach in dealing with reliability. That's the main data I had. And so any questions?
I'll go ahead and go first. I just had a couple of questions. You used the word criticality a lot. And could you just kind of unpack that and what makes something critical?
Several factors. It's location within the system. Some of our feeders are so closely spaced that one particular substation may be a load transfer point for multiple subs around it. So one of those subs is pretty critical because if you have an outage on any feeder on those adjacent substations, you can singly transfer an adjacent feeder to that substation without overloading equipment. Also, a factor that we put in there is looking at the customer base it serves. So if it has more critical customers on it, from that standpoint, it's water treatment facilities, hospitals, those type of facilities. Those are critical facilities, and we want to give those circuits a pretty good look over because of the critical nature of maintaining that for life, health, safety. So those are the main two things that we would use in determining circuit criticality.
And so I heard resilience and who's connected. Those are two biggies. Okay. And then is PNM on a similar idea as El Paso trading $1 of O&M for $10 at Capitol? A structured approach this time. Yeah. Similar question to EPE is just how's I understand how projects get defined and put on a big bucket list, then how it ends up getting. I used to joke, draw on the fat crayons to take it into the senior management group. Who's carrying that in and how does the decision for where the money gets spent and whether it's spent on O&M or capital, just what's the process for that? And again, who is the person who's carrying that in to get the funding, understanding criticality or?
Yes, decision-making on prioritization typically will fall with us at the director level. We will look at several factors and is it an economic development opportunity for the system? We look at safety for not only our personnel in operating the system, but for public safety. We look at environmental concerns. Reliability is a factor in that decision, in the decision space. We look at system performance. So areas where we're reaching with load growth on the system where we're running out of spare capacity, we look at those type of issues and that impact on outage restoration. And so that system performance is a factor. And then compliance related issues and as a director team, we put together these budget packets and we go through the justifications of how a project may fit within that framework and determine a criticality of each project. You know, where does that project rank? And we put those projects together and look at those evaluation categories. Reliability, safety, performance are really going to drive some of it. We have some contractually obligated economic development. So those are things that we're contractually obligated to do for some specifically lately large industrial type customers. And so we're contractually obligated to do economic development, and then we prioritize all the rest of the work based on those other factors. And the directors have that discussion about which projects do we need, and we will alter the priority of projects and move projects up and down in the list. And we'll come up with our cut line of, okay, these projects are the projects we're going to undertake, because the projects that fall below it are not rankings high in some of these factors. So we will automatically cull it. Once that package is put together, we present that to our senior leadership and go through that process and make sure we can explain to them the reasons why the decisions were made the way they were, and justify it before we ship it off to our board for approval. So.
No, I appreciate that. Really, I guess what I was getting at is the cut line. Is that tied to criticality of need, or it's a number that's given to you and then you have to figure out how to live within it?
It's a question I'm not prepared to answer, because for me, I've got some little more limited budgets on the operations side of the business. So I'll talk about the criticality of my things of trying to do system resiliency work and do that, which is not a major portion of our capital program at PNM. You know, a bigger chunk of it is some of the infrastructure improvement projects, economic development projects where we're doing equipment replacements. We have quite a number of pieces of equipment out there on the system that are approaching end of useful life. We're talking in the 40 year age range, 30 to 40 years. And so some of those are really going to drive it, because it's a performance reliability function of, hey, we want to be proactive. We want to replace it before we have a failure. So those migrate to the top, but our engineering folks do a great job in putting together those justifications and talking about why. There's not a lot of offsets between, we have budget parameters set for us and I believe by the board.
It's part of a long-range plan. So we do a 5-year long-range plan that defines the overall capital spend. And then we develop an annual operating plan based on every individual year. So that's what he's talking about, referring to the project. So within that set of capital spend, we do have some flexibility in there that are time sensitive, that there are projects that are must do's that have to get done within the year. And there's also some flexibility to move things as well year over year if we need to, based on criticality, more system changes, parameter changes, other things that can influence significant cost shifts are generator interconnects, economic development, capital spend opportunities as well. So there's a lot of factors that go into it, both from a 5-year perspective and from a 1-year perspective.
Thanks. I mean, I'm just trying to figure out, does need drive the dollars or does dollars drive the need? And one of the things I think I heard is this piece of it is small. So does that mean you're funded, or does that mean you're ignored, or is it somewhere in the middle?
It's funded. System reinforcement, equipment replacement are all a large chunk of the budget. You know, I don't have an exact breakdown of the split, but it has been consistently funded in my time at PNM.
Those are my questions.
one of the tables you have here on plant additions, reliability, you've got, about 25 million last year out of a total of maybe 130 million. Is that right? Could you, I guess, talk about what you would define as a, reliability project versus other distribution projects?
Reliability-based projects are going to be system reinforcement, which is replacing poles, cross arms, physical hardware type issues, cable replacement, transformer switch kind of replacement projects. All of those types of work are intended to improve the reliability solely. I mean, that's really the focus of those funding projects, is to just solely to replace equipment at the end of its useful life, so that we're trying to prevent outages from occurring. Other types of capital investments, as we talked a little bit about, are economic developments where we're doing large scale expansions for customers. It's interconnection of generator projects. I'm drawing a blank on the other ones.
And that's where, as the El Paso already noted as well, oftentimes projects will have multiple benefits. So it is pretty hard to say this explicitly reliability when you might have initiatives, even for economic development or others, that might provide overall system reliability improvements. So it's not always as easy to put it into a single bucket.
And how does data get into your outage management system?
Data is entered into that system via our system operators on the distribution side specifically. So they are entering in all outage information, whether it's driven out of our SCADA system. As we do partial restorations to bring customers back, we have our field team doing switching, and or we do automated switching. And so when those switching steps occur, they'll do those partial restorations. But it's incumbent on our distribution operators to fill out all of that data in outage management. And then we have SCADA engineers and supervisors and managers in that operations team who are going back over the data after the fact and verifying the times and which switches were closed to do those partial restorations to try to provide the highest level of accuracy for those reliability data. But it's driven out of our distribution operations center.
Great, thank you. So it's sounds like a largely manual process of checking the times that certain circuits went out versus when they were restored, and manually entering that in the system.
Yes, our operators do a fantastic job. They have a desk log. So anytime they do an operation, they're logging the time for every one of those operations and what they're physically doing in the SCADA system or doing with crews in the field. So with that data, that's it. It's the reconciling after the fact. Once we kind of get past an outage event, then they're going back in and they're entering those numbers in after the fact and getting it in the system so that we can run our metrics off of them.
Great, thank you.
Thank you for the presentation. I have a question on the top 5 outage causes. So the first one is trees, and as you explained, this is related to mostly the high winds due to weather events. First, I'm wondering if you have this information based on like geographic information, like where is this occurring? Is there a trend or is it just overall throughout the system?
It's not throughout the system. It is really in individual locations. We see far more vegetation related issues in the Ruidoso area, which is really large pine forested area. So we see vegetation affecting our operations there. Then the next pieces are in the Silver City area and in Santa Fe, where we see more Pino and juniper type forested areas. And that stretches a little bit further to the east, headed toward Las Vegas, but we see a little bit lesser impact in those areas. Anywhere along a water course in New Mexico, you have a higher density of cottonwood trees. So in and around the valley in Albuquerque, and not specifically the Bosque, but everywhere in the valley, we see a high density of cottonwood trees causing issues for us. So areas close to a water course or an arroyo, we tend to see more vegetation related issues than we do in other parts of the system.
Okay. And then with respect to the vehicle caused outages, the same question, is there like a specific geographic area where that happens more?
We're seeing more of those along major thoroughfares, specifically in the Albuquerque area. We see it's more spotty in the more rural or smaller towns, but in Albuquerque Metro, we're seeing a lot of it along the major thoroughfares. So those main arterial streets is where we tend to have the most damage. And it's also problematic because it's an area sometimes that gets difficult to work in, because we're having to take a lane whenever it occurs to then set up to do the replacement. So some of those replacements take a little longer. You know, we've seen a few lately that take 8 to 10 hours to get a pole replaced. And again, it's that timing before EMS clears the scene and gives us the permission to go to work. We get our underground locates going. We'll call them in the minute we know about it, but those folks can't even get into locate until the site's cleared. So it just delays those restorations because of the nature and location of where they've been occurring.
Okay, thank you. And then just with respect to the second one I see on here, which is cable fault, is this just like equipment failure not related to, you know, something else that caused it, like obviously not trees, because that's a separate category, but
no, cable failures for us have been really end of life type of failures on our cables. There's cables most recently late 70s, early 80s vintage cables that we're starting to see a higher density of failures on. So it's just they're finally reaching the end of their useful life and we're seeing those failures. And so from the engineering perspective, they're focusing on those developments where that cable is installed. Once they see the number of outages, then they start into planning to do those replacements. And then we get out and we start, you know, getting the infrastructure in place. So a lot of those cables early on when PNM installed them, they were direct buried cables. So we're having to go back in now and drill in conduit so that we can replace that cable more readily in the future. But it's just trying to future-proof that system so it'll be viable for a lot longer. So that's some of the issues now. We'll have to go back and repair it to get customers back on. So we'll have to just go dig it up and splice it back together. In the future, what we hope for is we'll install new conduit when we do the replacement. And then we'll just be able to pull that cable out, pull new cable in and re-terminate and get customers back on quicker.
okay, thank you. And then I'm looking at the table that has the customer outage duration. And I guess I just want to observe here that it seems like the durations that are of 4 hours and 8 hours are sort of going up, and the ones that are longer than 12 hours are either the same. So I'm wondering if this means maybe you're getting better at or quicker, you know, that they're getting shorter and shorter, or how can we sort of interpret this?
I think our crews, I would go back to our crews are getting better at getting those responses. You know, they have got practices now which will enable them to do a little better job of getting in and trying to get these outages restored as quickly as they can. So we have quite a few areas where we're seeing failures are rear lot residential, where the cables were physically installed in the backyard. We have invested in a couple of backyard machines, which will allow us to carry transformers back there, replace poles in the back lots. We have a machine to actually dig it instead of having to hand dig it. You know, a lot of those locations, if you've got a crew going out to hand dig a pole to replace a pole in a backyard, you're looking at 4 or 5 hours to dig a pole hole, where you can do it in 15 to 30 minutes with a machine. So we've invested in equipment and technology to be able to drive this machine into the backyard. It'll fit through a 4-foot man gate, get in the backyard, drill a hole. That piece of equipment with the boom on it will also allow us to take transformers back there on a pad mount situation. If we have to replace a failed pad mount transformer, they can carry it in on the equipment, set it off, maneuver it, position it faster than they could with the old pole jack system we had. So we're investing in that equipment to make them more efficient, to help them get these jobs done quicker.
Okay. Thanks for that explanation. And my final question is the same one that I asked El Paso. You know, is there anything from doing this exercise that you know you have learned so far? And that sort of sounds like we're done with it. I know that we're not. But anything you see so far on how you can improve?
Not really. And the reason why I say that is because we've been doing reliability metrics for 20 years. And so we've been monitoring those trends, and we've been trying to be proactive and not having repeat performers on our worst performer list. So we focus on that top 10. And then once we're good work orders working on fixes for those, we'll start our patrols for the next group. And we just keep working down the list, and we're trying to be far more proactive. And so in more recent years, we're really digging into that list and trying to get as much patrolling done as we can and documenting where we have deficiencies on the system so that we can get out and get those fixes done. You know, as we go through the data, we're working more and more in being more judicious on where we do fixes. Early on, we were just applying fixes. If we had a feeder, we would just fix the whole feeder. And now we're looking at specific locations where we've had problems. And we really want to focus our patrols on those areas first, which gives us a little more immediate relief for issues before we go back and start doing wide scale. So we're trying to be more judicious with the type of work so that we can impact more of these feeders each year to try to clear them off the list. No matter what, we're still going to have outage codes. Things are going to break, things are going to fail, trees are going to grow into lines and fall over. So there's things we're not going to be able to control, but for the things we can, we're trying to be as proactive as we can.
Thank you. That's all I have.
Commissioners, I have 2 questions, if I may. Mr. Gray, thank you very much. You might need to refer to one of your other subject matter experts for these questions, but on the worst performing feeders, I have noticed that it seems to be an effective program in that you don't have repeaters from year to year, at least in the data you've given us. But one trend that stuck out to me is that in the most recent numbers, 8 of the 10 identified circuits are now in Albuquerque metro area, which seems to present several complications that you have alluded to. One of them being that more customers are affected, that it may take longer to restore the service and those things. Can you talk about kind of the different challenges that you're facing with this migration of the problem feeders to more urban areas?
Yes, you know, some of the factors that we face, and I've mentioned a few of them before. It's rear lot construction, and as we go through, it just provides us issues with access to be able to readily get to those facilities, whether they're poles or pad mount transformers in backyards. It's difficult to replace. So as we go through and we start working on in a more urban environment, we look at, is there opportunities there to relocate and move these facilities to front lot? So that we have easier access, it's faster for us to troubleshoot. Some of the other factors that we deal with in a more urban area is lines along major thoroughfares. We talked a little bit about it as far as the restoration efforts. It's the same thing. If we're going to do major feeder work along, arterial streets, it becomes problematic because you're taking a lane and you're dealing with not only having to try to get the work done, but the safety of the employees out there working. And so those challenges of dealing with traffic, and we don't want to impact traffic flow as best we can, but we have to get in and get that infrastructure replaced. I mean, we're really looking at trying to improve the quality of service for our customers. So we have to walk that fine line, that balance between safety and trying to get the work done. And the guys do a great job. I mean, we'll take whatever space we need to get in there, but the guys are constantly strategizing, hey, can we get our truck on private property? And they'll reach out to that property owner and say, hey, we need to replace this pole, this piece of equipment. Can we be on your property and just temporarily occupy it so we can get this done, and try to work with them instead of taking a lane. So we're trying to be, innovative as far as reaching out to our customer base and talking to them and trying to figure out the best way to get this work done. In some cases, there's not going to be a convenient time to do it. We really don't want to try to impact. We want to try to have as little impact on people's lives as possible. Sometimes we have to take outages, but we try to schedule that as best we can when it's going to have minimal impact. So that we're not really impacting, but it depends on what we need to replace and where it is. So sometimes we're having to take outages at times when people are not real conducive with it. We try to schedule things at night. We try to schedule things. If it's in a residential area, we try to schedule it during the workday when people might not be home, but we do run into those. People are still working from home, and we got to try to balance it out. So we do all of those types of things to lessen the impacts as we work in a more urban area versus some of the rural areas.
Great, thank you. And of course, the more customers are impacted, the more complaints you get. Was there a question from the dais? Follow up on that? No. All right. One more question is, Judith, did you have a question? I see you're waving your hand. No.
Yes, but why don't you finish and then I'll ask.
Okay, it's a different issue, and we've been talking a lot about the standard reliability metrics under IEEE 1366. I've always had a problem drawing a direct line in terms of measuring effectiveness of activities to changes in SAIDI, Katie, mostly because of the volatility from year to year. But in particular, because trees are a big cause of outages for you, and vegetation management is a big component both of your operations and also of your wildfire planning, can you talk a little bit about the metrics of effectiveness of vegetation management? And not talking about how many trees get trimmed or how many square miles of grasslands get cut, but how can you really measure the effectiveness of these expenditures in vegetation management into reductions in wildfire, reductions in outages, improved service?
As previously stated, we see a lot of wind pushing branches into the lines. In Ruidoso during last year's windstorm, we saw a lot of actually trees breaking. Whether at the ground line, we saw some break just below the vegetation level on the trunk and snap, and the top of the tree blow into the line. And in those areas, if that's a major driver for SAIDI and we get out and we do vegetation clearing, we see benefits with that immediately. That's really a short-term resolution for it. One of our feeders from last year, Fort Marcy 13 here in Santa Fe, was our number one. High number of SAIDI, widespread outages on the eastern side of Santa Fe throughout 2022 and one into early 23. That circuit was patrolled in early 23 because it was a worst performer. It was patrolled first, and we got out there and did some vegetation management on that circuit on the main feeder portion of it. And so through the spring months here, with all of the wind we've had here in Santa Fe, we've seen significant impact. It's not anywhere near the top 10. There have been relatively few outages on that circuit, but none I contribute to trees. So we see big benefits in doing veg management on underperforming circuits. And we see those benefits right away. So that's why it's really one of our chief strategies in the short-term solution, especially if that is one of the major causes of outage duration for us.
Great, thank you. Judy?
Yes, you mentioned that PNM was in the bottom quarter or bottom first quarter and top second quarter compared nationally. And why do you think other states utilities might be higher performing? Do you think it has to do with the wind and the trees? Or are there things that you can learn from the other states and perhaps integrate?
My philosophy is you can learn from anybody and what their practices have been and how they perform the way they do, what practices, what technologies they're implementing to try to improve reliability. And so we are heavily invested in our peer groups, in information sharing amongst our peers to try to figure out, hey, how is our process? What are we doing that we view as successful? We talk to them and say, hey, where are your successes? Where are your failures? And it's things that we can learn from. So we're constantly in the mode of trying to improve our process. And so we do a lot of that, whether it's professional conferencing, whether it's through just individual contacts with our peer utilities. We've got those relationships in place where we reach out and say, hey, we've got this issue. What are you guys seeing? What are you doing to remedy that? And so it's just that information sharing and that benchmarking which really helps us try to improve the program.
And is that largely through the Edison Institute that you were talking about, through benchmarking, or is that in other forms?
It's in other forms. We do participate with Edison Electric Institute. We also are members of the North American Transmission Forum, so we participate in that, and we have various functions that we do with them to try to improve our processes. We just went through a process with them last year and come in and do a peer-to-peer audit of our vegetation management program. And so with that, we came back with no major findings, but a series of recommendations from our peers about how we can improve our vegetation management program. And then it's incumbent on that team to work on how do we implement those recommendations and how do we put that into action. So we do that, and we participate in IEEE conferences, other types of technology conferences where we're out there talking to vendors and looking at new technology. We talk to manufacturers, we talk to our peers. So there's a lot of that information sharing.
Actually, that was another question I had. Do you or other states use, like drones and other things like that to get to hard to reach areas or to do vegetation management surveillance?
We haven't used drones on the vegetation management side. We've used them sparingly. Really on the veg management side, it's been terrestrial patrols, guys actually out driving, walking line, looking at it. We utilize a combination of internal foresters, external foresters to get out and get eyes on and really try to figure out where we are in veg and then come up with, hey, what do we need to do for these line segments to try to clear it? We did, as I mentioned earlier, we did do a LiDAR survey that we are still in the process of doing analysis on because we're doing some comprehensive work with that data. But we are piloting a satellite-based technology that we discovered last year that they utilize satellites that are flying over the continental United States about 2-3 times a day. So we have a pretty good database available to us to look at patterns over a period of time. And so the foresters are just really starting to dig into utilizing that advanced technology to help them. And through that, there are analytics that go with that imagery software that help them identify things that they may not see if they're just manually looking at a line segment on that satellite data. It'll help pick out points for them. So that technology is still maturing, but we are starting to pilot those type of technologies to help improve the program.
Mr. O'Donnell, if you don't mind my interjecting, we've been at this for a couple of hours. I just wanted to see if folks might want to have a short break. Would that be appropriate to have maybe a 10-minute break?
You anticipated my next question, so.
Okay, great. Let's should we be back in 10 minutes then? It's 3:34, so 10 minutes from now. Great. Thank you very much. We appreciate it.
Mr. Chairman, Commissioners, thank you.
Oh, I believe that we're back.
Yes, we're back.
Great, thank you. Commissioners, we have one more presentation. I want to thank Southwest Public Service Company for its patience well, it's a long afternoon. I see that Zoe Lees is in the room with you, and Casey Meeks is going to be doing the presentation on Zoom, and I see that he is here and presumably ready. Zoe, would you like to introduce Mr. Meeks?
Yes, thank you. Good afternoon, Chairman, Commissioners. Thank you for having us. I'm here to introduce to you Casey Meeks. Casey is our Senior Director of Distribution Operations. And he is today helping with restoration efforts in Perryton, Texas. So thank you very much for your flexibility in terms of the agenda today. Perryton did experience a tornado early last night. That was pretty catastrophic for that community. And our thoughts are with Perryton today as they work on restoration and search and rescue efforts. As you saw from our bench request response, our outages, the causes for our outages are, the majority of those causes are weather related. And we have been experiencing some pretty severe weather in our service territory this past month, as you heard from my colleagues this week at the open meeting. So Mr. Meeks is here. He is helping with the response to those severe weather events. So I thank him very much for giving us his time. This is an important effort, and we recognize that. And with that, Mr. Meeks, I'll hand it to you.
Thank you, Zoe. Can y'all hear me okay?
We have a little bit of static. Maybe you could be closer to your microphone.
How about now?
Better, thank you.
All right. See if I can get the right page here. Okay. Can you see my screen? Oh.
Yes, we see it.
Okay. Can you still hear me?
Yes, sir. Go ahead.
All right. Apologies for a little delay there. I think I had a network issue. So just to verify, I'm not sure which screen I'm sharing here. Are you seeing the PowerPoint presentation or are you seeing a PDF?
I can't tell. It looks like a PowerPoint with a helmet and a thermos.
Yeah, good enough. I'll roll with it here.
It's
So
PDF. Yeah.
okay, thank you. It's I'm not used to Zoom. We typically use Teams, so it's a little different technology for me. So I appreciate the time today. Heard from a couple of colleagues, I guess, and so I think I can probably maybe make this a little more brief than I had originally anticipated. Interestingly enough, as I was listening through El Paso and PNM give their presentations, I was actually a bit surprised at how similar some of our results were, specifically on the financial metrics that were shared. So not sure exactly what to make of that today, but I think it is something to consider. And I think I'll have some commentary when we get to that last slide of my presentation to maybe compare and contrast just a little bit the differences in territory and my opinions, I guess, on the things that I feel like drive reliability. So going through the data, see the Safety Katie results. Similar to our peers, Xcel Energy as a whole, SPS, if we look at both our Texas and New Mexico territories, or in this particular case, that this is a state-specific slide, we would fall solidly within the top quartile of investor-owned utility performance. We typically strive for targets across SPS with the exclusions of somewhere around 100 SAIDI minutes. That's kind of our typical target. Obviously, our New Mexico footprint is just a portion of it, and particularly for the customer count in New Mexico, for our portion of the territory, it's about a quarter of our total SPS footprint. So the metrics do look a little different if you look across all of SPS. Also of note, the rural nature of our territory in New Mexico, I think is something worth mentioning, and I do have a slide that just shows the geography to give a little more perspective there. Most utilities have some fairly significant urban areas. While we do have some cities in southeastern New Mexico, they're relatively small cities, and the amount of infrastructure that's dedicated to those to service to customers in those cities is a pretty small percentage of our total infrastructure. And so, our results are I think, indicative of that across the board. And specifically, maybe I'll touch on a couple of things that I think are observations from the data that you might could see that geographic footprint kind of come out in. So a couple of things to mention on this slide. I don't necessarily think that these metrics, whether we look at SAIDI, safety, or Katie, and I will say that as a company, we do focus on these three primarily. SAIDI specifically is typically on just about every level of our operations leadership scorecard throughout Xcel Energy. So SAIDI, it is a big focus area of our company, but I will say that I don't believe any of these metrics in and of themselves really tell the whole story of reliability. And in my mind, there's two components to reliability. You have the reaction to events, which is obviously something that our customers are very aware of. But then you have all the work that goes on into the system in between the events, which a lot of times our customers aren't aware of, or at least if they are, maybe it's tangentially with regard to the costs of their bill. So two different aspects, and I think both aspects have to be considered. And I don't necessarily think that any of these metrics are clearly indicative of good performance on either. They can, and there's definitely some areas that you can draw some correlations, but they in and of themselves don't tell the whole story. So I think it needs to be a bigger consideration than just what the metrics show. Again, that said, we do run top quartile in our safety performance. Moving on to the outage, sorry, the right one here, to the single outage durations. One of the commissioners, and I apologize, I can't remember which one mentioned it, but asked a question about the trends over time. Notable to me, and as I was pulling this data, is one of the things that was a bit surprising, that our average over the last several years is quite a bit higher, particularly on the greater than 12-hour duration events, customer impacts, than it was a decade ago. I think part of that is the fact that we've added a significant amount of customer base to our New Mexico territory over the last 10 years, specifically oil and gas, heavy industrial customers with a very rural nature to their service. And so, I'll touch a little bit more on that maybe here in a minute, but the methodology that we utilize to restore power in an outage event does give priority to our residential customers. Typically they're much more aware of impacts to their service than are some of our oil and gas customers. And again, since I'm on the topic, I might also mention that oil and gas customers in southeastern New Mexico also are typically primary service takers. So they take service from us at the medium voltage level. They have fairly extensive distribution infrastructure that feeds their individual well and service locations. And so often they have damage on their systems as well that takes time and effort to restore. Granted, these numbers are to our service point, but that just speaks a little bit to why we prioritize our residential small general type customers ahead of some of our oil and gas type customers in the area that we serve. So I think that's a little bit of the reason. As far as the question about what have we learned from this, this is definitely one piece of information that I'm going to explore further with regard to what we're doing on our system. Next slide here, the exclusion days, and I won't spend a ton of time here. As has been mentioned, weather is absolutely the primary driver of these reliability results. When you look at the exclusions, you'll maybe notice some trends here, and specifically, I've been in this role for a number of years, but prior to that, also with construction and engineering in the utility business, and so some of these storms are clear in my memory, even back to 2015. That December event was a massive snowstorm titled Goliath that hit the far eastern New Mexico area, Clovis, New Mexico in particular, up through the Texas Panhandle. So that one I remember well. You look at 2019 in March, that was a bomb cyclone, multiple days of extremely strong winds that hit our full footprint. We had damage all across our territory. It was a long several days. You get into summer of 2020, we had some substantial heat down in Carlsbad, New Mexico. I think we hit about 115, 116 degrees. So loading on the system was definitely at a peak, but areas of our grid were hard to keep on with that level of loading. So we had to scramble and do some things there. So anyways, I won't belabor it, but these days, and again, you'll note that several of them are single events. So the day of the event and shoulder days where maybe it wasn't the heart of it, but definitely we had those shoulder events that basically would all point to a single weather event that caused those exceptions there. So just a quick comment on geography. Again, SPS has a very large rural footprint in New Mexico, probably a little different on customer base from most utilities. 60% of our sales are to large commercial and industrial, specifically oil and gas customers. You'll note that we have fairly big geographic footprints in the Lee and Eddy County areas. We have basically the full southern 3/4 of Lee County and about the southern half of Eddy County. So a little different situation than some utilities. If you look at the Roswell, Artesia, Dexter, Hagerman, and Clovis and Dallas area, up further north, Tucumcari as well, if they're on an island. Those are a little more traditional for the investor-owned utilities, where we have co-ops, surrounding those incorporated areas. Worst performing feeders, and similar to what you've heard here, we do keep close tabs on these poor performing, we call them poor performing feeders. But we do keep close tabs on these. We do focus time and dollars on ensuring that the same feeders don't show up frequently on the list. We have multiple programs that utilize that data to try to impact these results. Another thing of note here, though, as I mentioned on the previous slide, the bulk of these over the 3-year period shown are rural, primarily oil field lines. And again, that goes back to what I mentioned earlier, where we prioritize our restoration efforts to our residential customers. And the oil field at times does take a little longer. Obviously, to get these relatively few numbers of customers out that are out of power in the oil field back into service takes an inordinate amount of time as well, with the travel and the terrain and the challenges there. Reliability programs, again, I mentioned we have a number that address the poor performing feeders, but just in general here, I'll just try to hit these at the high level. We generate work orders for every momentary outage at the breaker level. So I'm assuming that terminology is familiar, but a breaker operates practically instantaneously on a first trip. Maybe it operates a couple of times to clear a temporary fault. If we see those momentary, not a sustained interruption, the customer may see a blink on their system. We will go ahead and patrol that feeder until we find an issue, or we'll patrol the extent of the feeder. And so we track those responses to ensure that we've looked at all of those over the course of time. We have feeder performance improvement programs similar to what El Paso and PNM mentioned on their program with those top 10 feeders. We do focus dollars on improving the cost codes that we're seeing on those feeders. Reliability exception monitoring and the CME, customers experiencing multiple interruptions, those both really speak to frequency of outages. And similar to FPIP, there's dollars in a programmed approach to trying to reduce those frequency issues. A little more into the meat here of our capital programs in particular. We have a proactive line patrol, which we call an asset health program. We look at every feeder line, every mile of feeder line that we have on a 2-year rotation. Those are typically foot patrols with a dedicated patrolman, so we get consistency of results and have quality of the issues that are found. Then we intend to look at the taps on somewhere between the 2 and 4 year rotation. So what that results in is let's just split the difference and say every 3 years we look at every line mile of our system. We identify the issues. We create individual work orders for each of the deficiencies that are found on the system, so that we can track the progress of our restoration or addressing of those issues at a very refined and granular level. We do also look at the completion of those corrective action items, the KPI for our SPS distribution group. And then as part of that program, we do allow our patrol personnel, the folks that are out looking at the line, to make suggestions on upgrades for the lines. If they see anything that would warrant potential addition of equipment or a larger project to address some issues such as aged conductor that may require multiple miles of reconductor or something along those lines, they will note that, and those issues go into separate programs, budgets of work to where we'll try to address those things as well. Pole inspection, treatment, and replacement program. So really several aspects to that. We intend to test a 12th of our entire SPS infrastructure every year. So 12-year intended rotation on that program. They will test every pole. They will treat every pole when the testing group is there. And then they will also note the remaining strength of those poles. If the remaining strength falls below a certain threshold, there are multiple categories of prioritization for replacement that those poles get placed in. And we do replace or truss a substantial number of poles every year as well. And then lastly, and there's probably more to this that maybe wouldn't exactly fall in the reliability program. I can think of a couple of other things that we do to address our system as a whole. They just wouldn't necessarily typically fall in the reliability category, but we also have what we call advanced capital program. So similar to what I mentioned on the reconductor, we look at our system holistically. We get input from our field personnel on areas of our system that could use attention, whether that be, again, aged conductor, lots of splices in portions of conductor. Maybe it's bottlenecks in switching capability. Maybe it's potential capacity issues that we foresee coming in the future. I think the El Paso folks mentioned proactive voltage conversions. So old 4 kV and 2100 systems where the substation equipment and other equipment associated with service there is aged and a little difficult to maintain, potentially at end of life. We count those as what I would call advanced capital programs that we have significant dollars associated with as well. But again, those don't necessarily fall into reliability. There's more to it than that. And then lastly, we do pilot new equipment, things like single phase electronic reclosers. A lot of our system is a 3-phase system, as I mentioned, with the oil and gas customer base, but in areas that are prone to animal issues, in town, schools, on lines, and that sort of thing. We have piloted some programs where we install new and different devices than we have historically used to try to improve our reliability.
Casey, I'm sorry to interject, but we are getting a lot of static. I'm wondering if you can turn the camera off your computer or laptop, and if that will free up some bandwidth without interfering with your sharing of the screen.
I'll give it a try.
Okay, let's hear you now.
Better?
Yeah, it's still there. We'll carry on. So you can come back to us if you wish.
How about now?
Oh, much better.
Yeah, sorry, it was on a different microphone, apparently. My apologies.
Thank you.
Okay, so the next slide here, just a couple of screenshots to kind of show some highlights from the programs that I just mentioned to you. Asset health program, again, proactive patrols results in corrective action work on the system from 2020 through 2022. And we just picked some dates there where we could pull quick and fairly readily available data. We've changed the methodology on that program a couple of times since we started it in late 2017. 2018 was really the first full year of patrols. But anyways, from 2020 through 2022, we've completed approximately 130 circuit patrols in New Mexico, 1,950 corrective actions to be addressed, and we completed 2,178. And some of those, the difference in numbers there, some of those were spillover from 2019. The screenshots kind of show the picture. You can see Tucumcari and Clovis on the left side, and then the southeastern New Mexico portion of the territory there on the right hand side. So substantial amount of work, again, all intended specifically for improving reliability of these lines. Pole inspect and treat program, again, just some numbers here for context. About 40,000 poles per year that are assessed and treated, or actually I think our total system count is closer to 440,000 poles in SPS at this point. So somewhere around that number, again, intended on a 12-year cycle. We replaced 4,300 poles in 648 of those in New Mexico, and then you can see the other numbers there. I won't belabor this. This does not include the numbers that were trussed, which are typically about a quarter of the call them issue poles that we find are candidates for trussing. Trussing is an economical option on some poles. We are selective with which poles we truss, but it is a portion of this program worth mentioning as well. And then a quick note, and I think this is apropos here. There's been a couple of questions about technology and kind of plans for the future. Our ADMS program is really just getting stood up in SPS. We're in the process of installing a FAN network, focusing on Texas right now. We'll move to New Mexico, hopefully later this year, early next year, and really start building out our field area network. Looking to also at some point start installing advanced metering as well. That's the first steps of this. A little further down, and I think much more potentially impactful to reliability is the Flisher. That's fault location isolation and restoration equipment. So basically automation on our system where it can sense a fault, open a switch, close a switch, and restore power to customers while isolating those damaged areas. And so I think there's a lot of potential for both the ADMS system, visibility from an automated meter system in our capability, where we can really make use of that data and try to find other trends that we haven't been able to see to date. So I think the AMI will be a great step, but really once we get to that point where we can install the intelligent equipment out on the system, it's going to make a huge difference for us, particularly in our very rural footprint where it takes crews, substantial time to respond to events out in some of these rural areas. And then the last slide here. Apologies for not making graphs and maybe making it as pretty as some of of my peers, but a lot of data on this slide. I understand it's a bit of a chart here to read, but I think there's importance to much of this. I know we had focused on some of the dollars and numbers here at the bottom, but I want to point out a couple things in our New Mexico territory. I'm assuming the commission may be aware of some of these, at least generally, but seeing it on paper, I think does have an impact. If you look at retail sales, megawatt hours of sales, 2013, 4.8 million. In 2022, we're at 8.9 million megawatt hours of sales. So, not quite double, but not too far from it either. That is a massive amount of increase for us from a system perspective in a 10-year period. Similarly, you look at the New Mexico line miles, 3,900 line miles in 2013, we're up to over 5,000. That's just increases in line, so extensions. In addition to this, because of the capacity and because of that load increase, we have reconductored and rebuilt probably about that 1,000 miles that we've grown. We've probably rebuilt about that much as well over the last 10 years. And then customers, again, the customer story maybe not quite so dramatic. Nonetheless, from a percentage perspective, it's still pretty dramatic. 98,000 customers in 2013, up to 117, close to 118,000 customers in 22. So massive growth for SPS, specifically on the load side. It has required a lot of infrastructure, investment in infrastructure, investment in capacity. That has taken a lot of dollars and attention on the SPS system. In the meantime, though, we have not forgot about reliability. We do have the programs I mentioned that are funded to a level that I think is extremely reasonable. And we are, continuing to look at that funding and adjust it as years go on to ensure that we do keep reliability front and center for our customers as well. Just touching on the O&M per and capital per metrics, you can see inflation adjusted O&M per megawatt hour significantly dropped over the 10-year period, started at 2.5. We're down to 1.3. O&M per line mile started at 3,000 and some change. We're down to about 2,300 in 22. And then per customer, which again, our customer base compared to our footprint, it makes this number a little skewed in my opinion, but 122 down to about 100 last year. Similar to what was mentioned, we do focus on capital investment. You know, we've had a lot of pressure to reduce, as has the entire utility industry, reduce our O&M spend. But frankly, in my opinion, our O&M by FERC accounting rules is really more specific to our reaction. It's more specific to restoration after an event. A lot of those costs roll to O&M rather than proactive planning, which are typically capital costs. And I'll also say the equipment that generally causes particularly long duration outage events is generally capital equipment, poles, cross arms, you know, the major components, reclosers, those sort of things. So heavy on the capital side. We don't have data back to 2013. We invested in a new working asset management software program that was put in place in late 2017. So getting the capital in particular back prior years is a little bit more difficult, at least at a granular level. So, you know, 2018 and beyond, but some trends there as well. 2022 capital per megawatt hour, 8.73, capital per line mile, about 15,000, and then capital per retail customer, 660. So that's the story. A couple things that I didn't mention here, and you know, without knowing exactly what to put in the presentation, happy to take questions on it, but I didn't add a whole lot about vegetation management. In our territory, it's not a critical concern. It doesn't show up, and in our filing, you can see the cost codes, which I didn't put in the presentation, but it's not a heavy consideration for outages in our territory. We don't have that many trees other than in our incorporated areas. And we try to keep those pretty cleared out. So that is an O&M program that we do spend dollars on, focused on our incorporated areas, but compared to most utilities, our tree problem is pretty minimal. Wildfire, pretty similar there. We do have some territory in southeastern New Mexico that would be considered more prone to wildfire, higher risk. We have stood up a wildfire program, or I'll say we're in the process of really getting it off the ground the last couple of years. Several aspects to that wildfire program, but I will say a lot of the things that I've mentioned that are causes for general reliability issues are also the things that impact wildfire risk. And so if you replace poles that are marginal on strength with better poles, if you replace cross arms that are marginal with newer, you know, fiberglass arms, those things also have an impact on wildfire risk as much as they do on reliability risk. So some of the same dynamics, at least again for our territory that doesn't have the tree footprint or the wildfire risk that our more forested areas of New Mexico have. So I think I hit all the highlights. Apologize if I missed anything that you were looking for, but happy to take questions.
Thank you, Casey. Commissioners?
Thanks, and you know, again, thanks for joining us today. I know you're busy, so I'll keep it just to one quickie question, I think. But you know, I appreciate you making this distinction between reacting to events and then what you do between events. And in the spirit of this whole conversation, is there a metric that shows that balance is well spent?
I'm not sure that I know of a single metric. I do think there are various metrics that can be viewed concurrently that do a pretty good job of telling the story. You know, for things like capability of the system, I think looking at similar event days across time. So, you know, again, it involves pulling in weather related data, really trying to look at how your system behaves against similar events over time. I think is about the best way that I can consider looking at that information. Unfortunately, it's a little hard to come by, and you know, don't envy you the task of trying to figure that out. But we have tried to look at that and provide some correlations, and I do think that is probably the best way of judging long-term performance of the system, both on response and ability of the system to withstand issues.
Well, thanks, and I didn't think I was alone in that task, so you're part of the team here, buddy.
Well, I guess I don't envy us that task then.
That's all the questions I'm gonna ask.
One question on your on, I guess, page 7 of what you sent us, this annual reliability report. Is that a typo, the 2018 SAIDI number?
Yes, apologies. I didn't catch that until today. It should be 106 since no MEDs that year, so it's the same numbers as the MED, the right hand side.
Okay. And the table 4, are all 3 of these years year to date April?
Can you help me out with table 4?
So I've got 10 worst performing feeders circuits. You know, it's on page 8 of the document you folks sent us. It says IEEE state normalized distribution lines only, and it's got the 10 worst performing feeders in each year.
That is a good question. I'm assuming we probably did that to baseline on 2023, but I'll have to circle back with you to get a good answer there.
Okay, that's fine.
And I'll just ask the same question that I asked before, although you did sort of answer this as you were going, but if you could maybe just recap sort of the room for improvement that you see, or, you know, if there's anything you notice that you might want to do differently.
Yeah, good question. I think the programs and the approach that we have to reliability is pretty well grounded at this point. You know, there's always something to learn, as Wes mentioned as well. I think if I could take anything away from the information that was pulled here, it would be to take a little closer look at the 12-hour, the 4, 8, and 12-hour restoration times, just to see if there's anything there that we could potentially incorporate or learn from. You know, beyond that, again, there's a lot that could potentially be done on the system, but it is a balance between capital needs in other portions of the company, other capital needs, you know, within the distribution world, balancing affordability for the customers. You know, there's a lot that goes into the equation of reliability. I will say, you know, on a primarily overhead system, weather will always have some impact, even if it's lightning. You know, it's very, very difficult with the technology that we have available to us to prevent all of those issues. And it at some point gets to be, you know, something like that 80-20 rule, where you start getting closer to being able to really prevent all the issues, and you're going to spend a lot of money to do it. So, you know, there's always going to be some component to reliability that we'll have to adapt to. You know, beyond that, looking forward to the technology that we have coming over the course of the next 5 to 10 years. I think industry-wide, there's a lot of potential coming from innovation. And I think if we can make use of that at the right pace and at the right locations in our system, it will definitely continue to help us.
Thank you. I don't have any further questions. Arthur?
Yes, thank you. I really just have one, and I want to thank SPS for including a copy of the required report that you give to Texas regulators on an annual basis, which looks to me like it's mostly about circuit health, right? It's every circuit that serves more than 10 customers, how many customers, and then the SAIDI numbers for that. Has there been any move in Texas in recent years to change the parameters of what they're asking you to report to them in reliability? I note that there is a new act that focuses on reliability at the transmission level, largely because of the winter storms in 2021. But has there been any effort to kind of broaden the statistics or metrics or results that you report to Texas?
Yeah, thanks for the question. I actually might defer a little bit to Zoe. You know, I do get involved in the Texas filing as far as pulling the data and having some members of my team that supports that. I had heard that Texas was looking at revamping their reliability reporting requirements on the Winter Storm Uri aftermath, but I have not yet seen any indications of that, at least that are impacting us. Right, we did file our Texas report in February of this year. It was very similar to what we've done in years past. I do think there was a little extra effort on an addendum this year, which was really around, you know, what have we done on those lines? So work performed and dollars spent on those poor performing individual lines over the time period. But beyond that, it's very similar to what it's always been. I'll also say that pre-COVID, we did used to have a conference with the commission staff on the report to discuss the report, and honestly, very similar to this meeting, to have a conversation about what impacts reliability. You know, what can we do, and how we might address that in the future. So since COVID, though, we haven't had an opportunity to do that meeting with the Texas.
Great. I'll just note that you touched on in your presentation several of the things I had questions about, so I appreciate that. That's all for me, commissioners. I'll turn it back to you for any conclusory remarks, but thank Casey and Zoe and all of our presenters today. We really appreciate it. It kind of went longer than I thought it would, but we got a lot of information.
I would like to mention we do have a place on our agenda for public comment. Are we aware of anyone who would like to make comment, who's present?
Patrick, were you notified of anyone who needed to make public comment?
Yes, Commissioner, we don't have anyone signed up via Zoom, and I'm not aware of anyone in the hearing room presently who wishes to give public comment.
Thank you.
Yeah, I know that we are planning on another session on July 7th. Commissioner Ellison, what are we going to do on July 7th?
Sure. I guess let me go ahead and talk about next steps, and then if Chair O'Connell or Commissioner Aguilera would like to make some closing remarks before we adjourn. So I think what we have envisioned here is a presentation on July the 6th by Joe Edo, who is a researcher at Lawrence Berkeley Labs, who is a well-known expert on electric system reliability. And after that, our intention right now is that we would get out a draft rulemaking to everyone on reliability reporting to the PRC. And then we would have a couple more informal workshops at which we would discuss that draft rulemaking, and those are the workshops that I think that Jason Ball from Lawrence Berkeley will help us in facilitating. So our hope here is that by getting out a draft rulemaking and then having a couple of informal workshops that we can really work through a lot of the issues, so that when we go to having a formal NOPR and proceedings, that we will have already worked through many of the concerns, and that we can get the rulemaking done relatively quickly. So again, our focus is, since I don't think we have any reliability reporting requirements at the moment. I think the focus is getting some reliability reporting requirements that make sense and that are useful. So that's the basic gist of what we're thinking about here.
Yeah, thank you for that. I'll go ahead and just offer my conclusory remarks and then give it to Commissioner Aguilera. First of all, thanks to utilities for coming in, providing the information, very informative. Then, the process that Commissioner Ellison just outlined is a good example, I think, of what we're trying to do on a number of rulemakings. We've got quite a few going on. They are all, I think, of high impact to how we're going to do our work in the future. Analogy that I use is, let's not try to film the movie without a script. So what we're doing now is trying to workshop the ideas as best we can before we get to the notice of proposed rulemaking, so that then the draft that's in the NOPR had at least had some development to it. So then when we get into the workshops and the rulemaking process, we're really hitting that at a high level and producing good rules to move forward. So just want to say thank you again to utilities, SPS. I know you've got a tough situation there, and admire how you've worked through that while keeping your people safe. And then thank you to Commissioner Ellison for leading us through this process.
Yep, I also want to express my gratitude for the information that was put together and, the presentations here. And I'll go back to, something I said earlier about the 3 IOUs really being unique, and that is really reflected here in terms of sort of the causes of outages and the approaches that you take to it. That being said, I do think there is benefit in having some standard reporting requirements, so that we are, aware of the how the system is performing, and aware of, and I know it, it is clear that you're all aware of what feeders you need to improve, for example, but I think it would help to make that more transparent and to ensure that we have some standard reporting requirements, and something that we could continue to build on in the future. And so again, just, thank you all for the information. I know that I found this to be very informative, and I guess we'll continue talking about this.
Like to reiterate as well, thank you to the utilities for the quick turnaround and for the informative presentations and answers to our questions that you gave. Thanks to Arthur O'Donnell for his work, as well as the Lawrence Berkeley folks for their support. We're going to be seeing more of them in the subsequent meetings. So thanks again to everyone for your participation, and look forward to continuing this process. And I think we are.
I learned the hard way. You actually have to say that.
You have to say it.